All right, good morning, students. We are still in Unit 1, as you can see, constructions and rigid transformations. We are on lesson 19, evidence, angles, and proof. Okay, the next slide shows our objectives or learning targets for the day. I can label and make conjectures from diagrams. I can prove vertical angles are congruent. Mastery of these two objectives are going to enable us to meet the state standard, high school geometry congruence, number 9, to prove theorems about lines and angles, specifically that vertical angles are congruent. And that is our goal for today. All right, our bell ringer is on supplementary angles. Now, these are previous lessons. This refers to the previous lessons we've been doing for about 2 days concerning angle relationships. So we've learned about linear pairs and supplementary angles. We've learned that they add up to 180 degrees. So using this previous knowledge, mentally evaluate all of the missing angle measures in each figure. I will give you about 3 minutes to complete this task. Okay, great. Now that you're done, as a teacher, when they're finished with the bell ringer, I would call on volunteers and I would go through each of these figures individually and complete them with the students. Next, notice and wonder. I would also have the students do this notice and this wonder. What do you notice and what do you wonder? And I would call on 2 students. I'd probably call on Jaden and Elijah, one to give me a notice and one to give me a wonder. Now we would move on to the heart of our lesson, which is called Diego's conjecture. And I would teach this lesson. Here's a figure where R ray meets line L. The dashed rays are angle bisectors. Diego made the conjecture, which is either a guess or a hypothesis. They're all synonymous. They mean the same thing. The angle formed between the angle bisectors is always a right angle, no matter what the angle between R and L is. Okay, so let's look at this diagram. So we have given information in the wording at the top. We have given information in the diagram below as well. So we want to use that given information to mark our diagram. That's always going to enable us to solve these geometric problems, okay? So first of all, we see that our line R intersects with line L. That's stated, okay? Those two intersect, we see that. And that the dashed rays are angle bisectors. So these rays are angle bisectors. So recall, and we've talked about this before using our vocabulary, bisectors. Break the word up into its root and its prefix. Bi, 2 for bicycle, right? Sector reminds you of section, like cutting something in a section. So 2 sections, basically. Now, what you need to remember is that they're going to be 2 equal sections. Okay, so that means on either side of the bisector, you're going to have 2 angles that are equal. Those 2 angles would be equal to each other, and these 2 angles would be equal to each other. Okay, that is given in the information that we have at the top. As well, now what the question is, the conjecture is that the angle formed by the bisectors, so you would have to find your bisectors, which we have located with the dotted lines in green, is 90 degrees. Okay, this is his guess, that this angle is always going to be a 90-degree angle. So what do we have overall? You should look and see that you have a familiar diagram. You have what we call a linear pair formed by a line and the one ray. You have 2 different angles. So let's highlight these angles. Let's highlight the one on the left in green. That's your bigger angle, okay? And then you have the one on the bottom. Let's highlight it in red, okay, right here. Those are your 2 angles that make up this linear pair. Now, what do we know about a linear pair? We talked about this in the bell ringer, and we've discussed it for a while. So we should know that they always add up to what? 180 degrees, okay? 180 degrees, good. That's going to be their sum. So the left angle, the green angle, plus the red angle at the bottom are going to have to total to 180 degrees. Now, the conjecture of Diego is each of these angles, the one on the left, the green one, and the one on the right, the pink one, have a bisector. That means that it splits them in two equal parts, right? Okay. He says, if that's the case, then is the angle made by those bisectors, now that's what we have marked here, always a 90-degree angle? All right, so now that we have our angle marked, the best thing you can do to get your group started is to assign measures to these two angles, okay? Assign a measurement to the green angle. Okay, this is just to get you started. And assign a measurement to the red angle, remembering what those angles have to add up to. Then you can further break it down and then go about problem solving to see if Diego's conclusion is correct. Okay, so those are your hints. Green angle equals red angle. Assign a measurement value. Okay, now I'm going to put you in groups. You'll see that you have your group roles listed here. You'll see which breakout room you're supposed to go into, and you'll see some further instructions at the bottom. You'll have 8 minutes. I will pop in and out of your rooms to check on your work and your progress as you go through this. Okay, so y'all are back. Great job. All right, I heard some really good math talk in the groups. I heard some people really problem solving and using some really good observational skills and using the information that they were given to come up with some conclusions. So first of all, I'm going to call on, let's see, Alexis is the speaker of your group to give me some of the numbers that y'all came up with. So what's the first thing you did? Okay, so you assigned a value to the green angle. Oh, you noticed it was bigger, so it would be probably a larger number, right? Okay, so what did you give it? 140. Okay, good. Okay, how about the red angle? And how did you come up with that? Oh, you know, they had to equal 180 degrees, right? So that would be 40 degrees. Good. Okay, so the red angle is 140 degrees. And I mean, the green angle is 140 and the red angle is 40 degrees. Now, were you able to further break that down in your diagram with the bisectors? Oh, you were. Okay, so the left side of the green angle, how many degrees did you put in there? 70. That's right, because it was going to be split into 2 equal parts, right? And then the right side would be 70. Good. And in the red angle, 20 and 20. Okay, so y'all did a great job of labeling your diagram, getting all the angle measurements correct according to your linear pair and supplementary angles. But were you able to answer the question? Is the angle between the bisectors always going to be 90 degrees? Well, let's see. Let's see, one of them is 70 plus the other one is 20. So that would equal 90. Good. So those two angles did add up to 90 degrees. Now, is it good enough to just have one example? No, we need at least 3, right, to prove a conclusion. In science, you don't do the experiment once, you at least do it 3 times. We need repetition and a pattern to prove that that is a conclusive or valid conclusion. Good. Okay, and as a teacher, I would now ask Garen to present his group's numbers and then Josephina so that we could get a pattern and a distinct conclusion for this lesson. Okay, after this, I would provide, I would look at the learning objectives and say, are we continuing to meet our objectives? Have we labeled and made conjectures about diagrams? And we have done that. Have we proved vertical angles are congruent? Well, we haven't met that one yet, right? But we can see that we're on our way. We've gotten 1 out of 2 done so far. I would also provide them at this time with a little supplemental sheet of problems for extra practice and work. Next is the independent activity. This would give me a quick check on where they are and if they have mastered what we're talking about in the relationship and if they can put together how vertical angles are related. So this states that here are 2 intersecting lines that create 2 pairs of vertical angles. What is the relationship between vertical angles? Write down a conjecture, label the diagram, and make it easier to write your conjecture. So I have 1 pair of vertical angles marked with red dots. And so I would have them label their diagram thus far. And then I would give them a few more hints to lead them on their way. And I would tell them to first find themselves a linear pair. Okay, so we would take this and we would find one linear pair of angles. So that would be two angles. You find your straight line. Then you're going to find your ray, which is right here. And that's going to give you your linear pair. So if I draw an arc from one side of that line to the other, you're going to have your linear pair, those two angles right there. You're going to have your larger angle and your smaller angle. Now, what do we know about those linear pairs? We know that they equal 180. So I'm going to tell them, secondly, you're going to label the angles in the linear pair. Okay. They're going to add up to 180, but you need to label each of them. You need to have a degree measure for the larger angle and a degree measure for the smaller angle. Okay. Knowing that they have to sum up to 180 degrees. And then the last hint I would give them is to also recognize that they have another linear pair right here. Okay. And to also next try and assign values to these. This measure will remain the same. You've already assigned a measure to this one. So keep that in mind when you're assigning a measure to this angle over here. Okay, and then you're going to have about 4 minutes to finish the convince me. Oh, great. Now that y'all are finished, Braylon, would you share with the class what your answer was? What is your conjecture about vertical angles? And I would continue to question Braylon. If his answer is correct, I would have him expand on it or maybe ask another student to expand on it. If it was incorrect, through Socratic questioning, I would lead them to the conclusion that vertical angles are congruent. So following would be a lesson synthesis as seen on this screen. We would just go over what we have proven, that vertical angles are congruent. We'd mark our diagram and go through it one more time, and then we would add it to our reference sheet. Next, I would assign this exit ticket for completion with the accompanying rubric so they could see exactly what it took to get a proficient, mastery, and/or advanced. And before releasing them, one more thing, I would go over the objectives for the day and the state standard. Did we meet the objective? I can label and make conjectures from diagrams. We did. Did we meet the objective? I can prove that vertical angles are congruent. Yes, we did. And therefore, we have met the state standard, which is listed below, that proving theorems about lines and angles, specifically that vertical angles are congruent. As seen, we started with the bell ringer, and that provided a review and the foundational knowledge that we needed for this lesson. We have learned in the previous 2 lessons about angle relationships, linear pairs, their supplementary relationship. So those 4 problems at the beginning provided them with some practice and some review and the foundations for this lesson's success. Then next was the notice and wonder. That just allows for the kids some observation, exploration, deduction, sharing of ideas and different perspectives. And then we had Diego's conjecture, and that really is the heart of the lesson, where I go into actually proving out some angle relationships and how to come up with them using specific diagrams and the given information that is known. I took advantage of group activity for this lesson so that I could differentiate for the kids, making sure that the facilitators were the advanced students and that the speakers and writers were the ones that struggled a little bit more. Providing that the facilitators would indeed facilitate, not give answers, but through questioning and maybe giving hints and prodding, they would lead their group together collaboratively to come up with some answers and a conclusion for Diego's conjecture. I would then follow up this activity with a supplemental worksheet of about 4 or 5 problems with examples of vertical angles and linear pairs to make sure that they have some extra practice on labeling these and assigning measurements to them and making those deductions. Following that was the convince me activity, and that provided for independent practice that gave me a quick check to see who was getting the information from the lesson, who was understanding it, as I go through and check on their progress. Then the lesson synthesis brings it all together, allows them to put it in their reference book, see it as a whole conceptually. And finally, the assigning of the exit ticket with the rubric would be my formative assessment, which would allow me to get that necessary data for mastery of that state standard. And that would conclude my lesson. Thank you.